Alright, in the second video we're going to learn how to solve logarithmic equations. And with logarithmic equations you have to check your solution. So with exponentials you didn't have to because you can plug anything into an exponent. But a logarithmic equation you can't take a log of a negative, so if you have a solution that makes the inside negative, or what you're taking the log of negative, then it's not going to work and we'll have to check that. So first thing that you need to do is get the log by itself, just like you need to get the exponent by itself. The second thing you need to do is rewrite your log as an exponent. And so this is with your shell snail. And then 3, you're going to solve for x. And then fourth thing is to check your solution. So we're going to do about 5 examples of these, and we're going to do some natural logs and regular logs. So first thing I need to do on this one is get this ln by itself. So I'm going to subtract 5 and then divide by 2. So let's subtract the 5 first. So when I do this, this is going to be 2 ln x equals -1, and then I'm going to divide both sides by 2. So ln x equals -1/2. Now on this, the base of an ln is kind of like base e, and so if you just want to kind of stick you a base e down there to remind you, that's what I'll tell a lot of my kids to do. So then I'm going to shell snail now that I've got the ln by itself, and so when I do that, I need to write this as an exponent. That's what this is going to do. So e to the -1/2 equals x, and then I can just plug that answer in my calculator, or you can, a lot of times they'll leave your answer like this, and so either way is fine with me. If you plug it into the calculator, let's go ahead and round it to 3 decimal places. Alright, so when I plug this in, I'm just going to plug in e to the -1/2, and this is going to give me 0.607. Okay, so x equals 0.607. And that would be my final answer. Now, I need to check and make sure that when I plug this back in to my function, it doesn't give me a negative inside the log. And so when I plug in the 0.607 right here for that x, it won't give me a negative, so that will work. And if you wanted to actually check your solution, what you could do is take this answer, and what I'll do is I'll store it for x, because if I round it, it'll cut off some of the decimals and it won't be exactly correct. And you can check your answer by just plugging this side in and using that 6.07 or whatever we got for x, and then it should equal 4. So if I wanted to check that, I'll have 5 plus 2 ln. Now that I've stored that answer for x, if I just hit x, it automatically thinks that it's the 6.065 number. And so enter, and that gives me 4. So you can check it like that to make sure it's exactly correct. But the main thing that I'm going to ask that you do is just make sure that whatever you get for your solution doesn't give you a negative inside the log. Alright, number 8. On one like this where you've got 2 logs or 2 natural logs, either one, you can't solve until you get them to condense to 1. So the reason that we did condensing is so you can use it to condense these so you can solve this equation. So I'm going to solve this doing natural log of x over x minus 1 equals 1. Now that I condense, that pretty much gets my log by itself, and so I'm going to go ahead and write this as an exponent. So this is going to be e to the first, or just e, equals x over x minus 1. Now, this one looks a little bit tricky because it's just weird having this e over here. But remember, e is just a number. E is just that number 2.71828, blah, 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 blah. It's just a number. So if I had just a number right here like 4, then what I would do is put this over 1, and then I would cross multiply. And the reason I can cross multiply right here is because there's an equal there, okay? And so then when I cross multiply, I'm going to treat e just like it was any old other number. If I multiply this diagonal, 1 times x gives me x. And then if I multiply this diagonal, I'll have e times x minus 1. Now, what I would normally do if this was just a regular number right here is distribute that number to the x minus 1. So that's what I'm going to do with the e as well. So I'm going to have x equals ex minus e. Now, remember, e is just a number. We're trying to get x by itself. So if I had this, x equals 4x minus 4, like I said a minute ago, then what I would do to get the x by itself is to subtract this 4x over from both sides. So that's what I'm going to do with this e. I'm going to say minus ex minus ex. These they cancel out right there. And so then I'm just going to leave it x minus ex equals negative e. Now, the last thing I would do, since we're trying to solve for x, so I want to get x by itself, is since there are two x's right here and this is an e, I can take this x out, okay, just factor it out, and then this is going to leave me with 1 minus e equals negative e. And so the way that I would solve this x is being multiplied by the 1 minus e, so I'm just going to take that 1 minus e and divide it over. So this is x is going to equal negative e divided by 1 minus e. And so this is my solution. If you left it like that, that's fine. But if I asked you to round to 3 decimal places, then we'd have to plug that in. And so I'm going to plug that in like this. Now, if you want to plug in an e that automatically has an exponent or a power raised to it, ready for you to plug in, you can push the second LN button. But if you want just the e like I did a second ago, you can hit second divide and it'll give you just regular e. I'm going to type in negative e, so negative second divide, divided by, and then everything in this denominator right here I've got to put in parentheses. So this is going to be 1 minus another e. And so when I do that, that'll give me that decimal, 1.582. Okay, so, or I could say x equals 1.582. Okay, either one is fine with me. And this one was a little bit of a challenging one. So 1.852, if I plug that back in, 1.852 won't give me a negative here. And then if I think about it right here, 1.852 minus 1, that'd just be 0.852, so that's still a positive number that'll be inside my natural log. And remember, you can just store that value that we got right here for x, and then plug that in and see if you get the correct answer 1. Alright, 9. I would pause this and try this one on my own if I were you, but after you try it, you click play and watch me do this one. So I'm going to try to get the ln by itself. So the first thing I need to get rid of, and that means everything on the outside of the ln. The 3 is on the inside of the ln, so I can't get rid of this 3 until after I do the little shell snail and write it as an exponent. First thing I'm going to do is divide by 2. So this is natural log 3x equals 4 divided by 2 is 2. And so then e is my base. I'm going to go ahead and rewrite this as an exponent. So e squared equals 3x. And so then I'm just going to divide both sides by 3 to solve for x. So this is going to be e squared divided by 3. E squared, and I'm going to use the one with the parentheses, divided by 3 is 2.463. Okay, so x equals 2.463. If I were to plug this back in, okay, 3 times 2.463 is going to give me a positive number. That's mainly what I care about, and so that's my final answer. Alright, number 10, if you have one like this, okay, you've got 3 logs, the easiest way to go about solving it is to get the logs on the same side and condense them. So that's what I'm going to do first. This is going to be log base 6 of, since this is subtract right here, when I condense, this is just going to be x plus 4 over x, and then equals log base 6 of x plus 2. Now, this one could be done a whole lot of different ways, but the easiest is by using this property of logs. And so there's a property of logs that says if we have log of a number, let's call it x, so log of x equals log of y, okay? The bases here are understood to be 10 if I don't put a base, so the bases have to be the same. But if I have log of this equals log of that, okay, then I know that this has to equal that, okay? If I have this, this also has to be true. So whatever's inside the first log has to equal the second, what's inside the second log. Okay, so one log has to be on one side of the equal mark, one log has to be on the other side of the equal mark. That's the exact same thing that I've got right here. So if you have this case, okay, we could not do this on this one right here because I had an ln on this side but no ln on this side. And so this is when I had the shell snail. But over here where I've got log base 6 of this equals log base 6 of that, I can go ahead and say that this and that have to be equal. Okay? And so I can solve that after I do that by putting that over 1 and cross multiplying like I did in the previous problem. So I'm just going to cross multiply. This is going to be x plus 4 equals x times x plus 2. Now in order to solve this, I need to distribute this x. So this is going to be x plus 4 equals x squared plus 2x. And now that I've distributed, I see that I've got a quadratic that I'm going to need to solve. And so the easiest way to solve a quadratic is to get everything set equal to 0 and try to factor it if I can. So I'm going to do that. I'm going to subtract x and subtract 4. And so this side goes away, so 0 equals x squared plus x minus 4. Okay? And so then I'm going to try to factor this if I can. And since I can't factor this one, if you go try to factor it, then that's not going to work. So I'm going to go to my calculator and plug this in. I could also use the quadratic formula, but the calculator is going to be a little bit easier. So I'm going to plug in x squared plus x minus 4. Plus x minus 4. And graph it and just find the zeros. And those will be my two solutions. And so then I'm going to go to second calc 0. And then go to the left of this first 0. Go to the right. And so my first 0 is negative 2.562. So x equals negative 2.562. And if I go find my second one, I'm going to go second 0. Go to the left. And then go to the right. That 0 is going to be 1.562. Okay, so 1.562. Now I'm going to look at both of my answers, and I'm going to check them back up here to make sure that neither one of them give me a negative inside a log. So if I plug in this negative 2.56 number, negative 2.56 plus 4, this is going to be positive, so it's okay there. But when I plug it in right here, I'm just going to be plugging in a negative number to this log, and I can't do that. So this one is not going to be a solution to this problem. Let's check this one and make sure. So 1 point something plus 4 is positive. It's positive, and I plug it in there. 1 plus 2, that's still positive. So this one will work. And so my only solution is x equals 1.562. And you can check it like that, or you can do the store thing and plug it in, okay, and try it that way too. Make sure it's the same. It'd be a little bit more involved to try it and make sure that they're exact same numbers, because you'd have to plug in one side, get a number, the other side, get a number, and then check to make sure those two numbers equaled. It's a long process. Alright, and then the last, there's actually two more that I want to do with you. And so with this one, there's a couple of different ways again that you could do this one. But whenever you have one that has an exponent like this, I think the easiest way to go about doing this is to, instead of going ahead and putting this base 10 there and doing shelf snail, I think it's easier to go ahead and bring this 3 down in the front of the log. So this is going to be 3 equals 3 log base 10 x squared plus 2. And so then when I bring that down, I'm just going to divide the 3 off, and that makes it a little bit easier, I think. So I've got 1 equals log base 10 x squared plus 2. And so now that I've got the log by itself, I'm going to go ahead and shelf snail. And so 10 to the 1 is just going to be 10. And so 10 is going to equal x squared plus 2. And so then I'm just going to solve it like a normal quadratic. The easiest way to solve this one is to subtract the 2 over. So this is going to be x squared equals 8 when I subtract the 2 over. And then when I square root both sides, I have to make sure that x is going to equal plus or minus the square root of 8, which is just going to end up being 2 square root of 2. Or you can say x equals plus or minus, and then 2 square root of 2 is just 2 square root 2 is 2.828. So plus or minus 2.828. Now, I've got to check that and make sure that both of these are actually going to work. So I'm going to check that negative. So negative, if I square a negative, that becomes positive, and if I add 2 to it, it's more positive. So that one's fine. The positive, if I square positive, it stays positive, and add 2, still positive. So both of these will actually be solutions to that problem, okay? But I wanted to make sure I did one with you that has an exponent, because it's easiest to go ahead and bring that exponent down and divide it off in the beginning, rather than rewriting it as an exponent first and then taking the cube root, okay? Alright, and then number 12, this one is a combination of exponent and a log. Okay, so primarily this is an exponential equation, so we're kind of going to review some exponential equations as we do. And I'm actually going to do this one in another video because I'm